Hello, team.
Oh, hello.
Hello. Okay, I'm a couple minutes early. Are we waiting on other people?
I believe most of the people are on campus, and they're probably going to join via shared device.
Okay.
Yeah, that'd be my guess. There should definitely be more people than this. I'm not sure exactly how they'll be joining.
Basically what we want to do is the number one thing is I definitely need to see the rocket. And then secondly, if you have a presentation, that's fine. If you don't, we'll just jump right into walking our way through the rocket. That's that's the name of the game.
That's the meeting started already?
Yeah, it's ready.
Excellent. We probably want to move it.
You want to use this one? All right.
So I heard a bunch of chatter. I don't know what the net of the chatter was. Oh, okay.
Hello. Hi,
Hello.
Ben.
Hi.
Hi, my name is Sophie. I'm the advisor for the rocketry team. And the team is trying to set up the rockets so that they can show you
Oh,
in the
perfect.
meeting. We
Okay.
also have level 3 flyer who's going to join us probably sometime soon.
Okay.
So yeah.
Is the level 3 flyer a student or is?
Let me check,
Or is
make sure the volume is high enough. Okay.
Okay.
Is Dave coming? Is Dave here? I didn't see Dave here. Is he here?
You should be.
Yeah, I can see.
Let's see.
Dave is not in the voice call.
Let me see. What did I do?
I imagine the actual time is free. Yeah.
I didn't see Dave in the meeting, so.
Well, the meeting is probably sorry.
Dave isn't in the voice meeting right now, no.
Can you turn them up? I can't hear them.
It's on. It's already all the way up.
They've turned.
Oh, there's Dave.
Oh, Dave's here, okay.
Is that as loud as it goes?
We are also still a minute early.
Can you hear me?
I can hear you at least.
Oh, hold on. I think I saw them. Hold on. I need to disconnect my. Give me 1 second here.
Not a problem.
All we have is.
It's using my. All right, hopefully. Hello. Hi, Dave.
Hello.
All right, here we go. Maybe.
You'll say this there, and then that way we can flip it off. Okay. Sorry, just another minute or two, trying to get everyone assembled.
Well, that's okay. Again, the objective here is basically to do a quick / thorough overview look at the rocket.
Sounds good.
Okay. Which means I'm going to need to be able to see the rocket. We're going to actually look at parachutes and shock cords and mountings and all that stuff. Okay.
Yep.
And I mean, the goal here is to make sure the team is ready to come to the contest.
All right.
Okay. And to understand if there's any obstacles in your way that would prevent you from attending the contest. So we could start wherever you want to start, or we could start at the motor end at the nose cone, but we're gonna basically walk through each part of the rocket, look at the structure and ask questions as appropriate, particularly interested in shock cords, parachutes, electronics, payload. I'm only really interested in how it's secured in the rocket. And if it's going to be deployed or not, then we'll get into recovery. But I, you know, my concern of payload is purely from a stability and a safety point of view, not from a functional point of view.
Yeah.
Sorry, payload.
Well.
So you can start however, and I'll start asking questions, or you know, we can start going from there. So it's informal, so.
Cool, Carter, come here. We'll start at the intersection with our fin cans.
Okay.
Can you carry that then? But you're gonna want to inspect all, so it's easier for it to be. Kind of like, just not a very heavy step. It's not, but so here's the fin can, we currently have, this is our prototype fin can. The tip.
Wait, let me stop you right there. You said prototype? Is
Yeah,
it-
so,
I need to see what's going to the contest, not what a prototype.
sorry, so this is, the second fin can, we haven't put the airframe over it yet. That's going to be assembled this week and next week.
That is, okay, are we talking two-stage here?
No. This is, so basically, as we started assembling this one, the one, this airframe right here, our fin flutter calculations, we went underneath the 50% safety margin. So we're working on a second one here.
We got a problem, folks.
Oh, what's up?
Well, when are you gonna have, you're not showing me the rocket that's going to the contest.
Okay, this will be done like within a week.
I've heard that before.
It will be done.
It will be done.
We can definitely get it done.
Can we go back again and explain what the problem with the existing fin can is? Why can't we just
The
use
fin
this?
flutter safety margin, it requires a 50% safety margin. These aren't quite hitting that. They're a little under. They were using another fin flutter calculator that didn't take in temperature. And so when we tested it against a newer one, these weren't quite hitting it anymore.
How close is it?
I can't remember super well.
Well, okay, let me back up here. Okay, here's my confusion, okay? I understand the 50%, I'm gonna ask another question, okay? But the red rocket that's next to that one, is that the one that's going to the contest? Or is that
Yeah.
just the fin can?
This is just the fin can.
Which will replace the one that you're trying to show me?
Yes. Same exact everything, just the fins have been slightly, the tip cord has been slightly elongated.
Okay, so I think maybe okay. For the rocket that's on the right, do you have the rest of the airframe done?
Yes, the airframe is all right there.
Okay, so roll it back. Go back to, get rid of that fin can you just showed me. I don't even want to see it. No, the other one.
This one?
Yeah, that's not going to the contest, right?
Correct.
Get rid of it.
All right.
Get it out of the way. Now, take the red one and put it in that position. Like you're gonna take it to the contest. Okay, now come down so I can see. Wait, okay, wait, that's. Okay, so that's just the motor tube with the fins attached.
Yes, currently.
Okay, and that's gonna fit into the green coupler or airframe next to it, right? Just to the left? Where's the joining body tube?
I'll go grab that. We have it.
Where's the booster joining body tube?
I'll grab that.
He's gonna
He's
grab
gonna
it.
get it. He'll be back in a minute.
Understand, I need to see what's going through the contest. Don't take, don't take this the wrong way, but I don't care what happened before.
Yeah.
Okay,
My concern is that we're not going to be test flying the new fin can.
well, I want to talk about what they use for fin, what they use to calculate their fin margin on, and, you know, did they use FinSim or did they use an Apogee article? Newsletter, which has problems. Um, you know, if they were 50% or slightly less than 50%, I mean, by how much?
Yeah, that's the question.
Right. This is the current tube for the fin can.
Okay, well, why don't you put it where it belongs then?
Got it.
Okay. All right, now describe to me the problem that you ran in with the fin design.
So, you emailed us that you were the fin flutter calculator. The
Which-
first one,
Okay,
and then-
whoa, stop there. What calculator did you use?
we were originally using the 291, and then we emailed you, I believe. And you said to update it to the newest one. And so we did, and the fin flutter calculator said that this was back under 50%.
Okay, so you used the Apogee, the most current Apogee one? Is that what I'm
Yeah.
hearing?
Yeah, we've used the most current Apogee one.
Okay, what did you use for the tensile strength of of the fins?
We moved it down to 600,000, like the one said. Because I couldn't find another source for the old one. The sources we had no longer exist. So I went with the 600,000 PSI that the new calculator states to use.
Hmm. Okay, by how much below the 50% margin were you?
With that 600,000, we were quite a bit below.
What's quite a bit?
What much was it?
10%, 15%, 30%?
Probably somewhere around 30% with that one. Just because of that, because we were running it at like 892,000 originally. That was the best we had. That's what we've been using for the past. But when it's set to go down to 600,000, and with the fact that temperature was warmer than what the original calculator said, we lowered quite a bit. That's why we have the new fins.
Okay. All right, so those fins look like they're a lot bigger than the other ones were, right?
Mhm.
Surface area? Okay, what size motor is the competition motor?
4 grains, 98 millimeter.
Full grain, 98. Do you know what Newton seconds on it are?
About 10,084.
Have you run a sim with the new fin structure?
Yeah,
What's your max velocity?
about 900 something feet. No.
Go get your laptop.
Can you go get my laptop? I have it. I had the numbers. I remembered them.
If you're at 900 feet per second, you're close to Mach?
And then we added a bit more weight and slowed the weight down. Oh, sorry, I'm pulling up the.
Those are
Yes, so the current velocity is 993 feet a second, or Mach 0.868.
Okay. And if you take your current fins and you put it into that particular fin simulation type of thing, that spreadsheet, what's the safety margin?
1 second, 60,000. 12%.
Okay. And your tensile strength or the pressure is, you said it was 6,000 for fiberglass?
So here also this is gonna be, okay, can you see that at all?
No, not really.
Okay, so it says to use a shear modulus of 600,000. Mainly as a safety margin to make up for the fact that we don't fully know where the shear modulus of Wildman fiberglass is. We were before we used this calculator, it was around 892,000.
Okay, all right, let me think about that while we're doing the rest of this. Given that motor, that's a Cicerone motor, right?
We're an SRAD team.
Okay, what motor did, you said you're gonna run a 4 grain 98, is it a Cicerone motor or an Aerotech motor?
We're SRAD.
It's neither. It's made by the students.
All right, okay, so have you done a static fire?
Yes.
Have you sent me the data?
Yeah.
Okay, all right. I've only got, never mind. Okay, all right, we'll still come back and talk about static fire. All right, okay, so 4 grain, all right. Okay, so all you really need to, okay, how, can you show me the motor retention that you're gonna use?
Here's a slip line from Giant Leap. It's cost.
Aeropack?
No,
Alright.
slim line.
Oh, okay, slimline?
Yeah, you get them from
Okay.
Giant Leap.
All right, that's fine. Show me the, your fins and how they're attached and describe how you attach them.
So what we do is we do an epoxy layer here, and then a fillet, and then we put it on the main airframe.
Mhm.
And then we're gonna do another fillet, and then we fiberglass over.
Okay, all right. So how do you do your surface prep? How do you do your surface prep? How do you prep the surface?
We
For the
wipe it down with 91% isopropyl alcohol, or sorry, we sand it first, and then we wipe it down with isopropyl alcohol.
Okay, all right. Okay, so that will slip into that tube that's there. You'll glue it in place, right? And it'll be attached. Okay, all right. Okay, now understand that. Now, can you show me the electronics bay,
Yes.
the coupler, the bulk plates, all that sort of stuff?
Or should we wait for V to get here? Yeah, is he not hearing his message? Our electronics sleep is 5 minutes out.
Okay. On that, on that coupler you just showed me, what, what's the length of the coupler from the, what's the length of the shoulder from, what's the length of one of the shoulders?
Of this?
Mm-hmm.
These are about 6.25 inches.
Okay, 6-inch rocket?
Yeah,
Okay, all right. Flip it around so I can see where you've got those holes. And you've got the epoxy.
yeah, so these ones here are adhesive nuts, mainly just to hold our drogue bay retainer, or just to hold our drogue bay on. And
Okay,
then these ones next to it are barometric holes.
okay, all right. So where's your shear pins?
Shear pins are in the drogue bay retainer right here. And then they go into the fin can coupler.
Right, okay, what size is shear pins?
We use two 4-40.
Okay, all right. Do you have the sled you can show me?
Yeah, we have the sled.
And do you have any electronics mounted on it?
Where is? Hold on.
Yes, we do. We've started to mount electronics on the payload. Payload.
The recovery electronics are gonna be on the payload?
Or not the payload, sorry. I've been mostly working on a specific subsystem. Yacheslav has been working on the main electronics. He's almost here.
Yeah. So, few minutes out still.
Okay, well, while we're waiting, what's, okay, I heard something about a test flight, Dave, did they? Can I get an idea of the experience of the team? How many rocket flights, what the team has done in the past?
So I was there for Spaceport America Cup 2023.
Okay,
I'm level 2 certified.
okay. Everybody
Um,
else is new?
Vyacheslav, our electronics bay guy, was also here for Spaceport America Cup 2023.
Okay, how'd you do last year?
We successfully recovered the rocket.
Okay,
We did pretty well last year. We're all of it's a 2-year college, so we got a lot of people every year. Better be here in 1 minute.
Yeah, we have a few. So yeah, we have a few experience and quite a few new people this year.
okay. All right, while we're waiting for that, let's move on to parachutes and shock cords.
Yeah. So all of our parachutes have swivels on them to make sure that we don't tangle them during flight. Currently, we're using a Lock Precision 36-inch drogue parachute. That flew with us last year and it works pretty well. And then,
Main,
hmm?
the main,
Yes, the main, right here.
The main is off frame. We can't see it.
okay. Are there any burn holes or any patches on any of the chutes?
Sorry, I couldn't hear you.
Are there any burn holes or patches on the chutes?
No.
No, okay. Okay,
We're using a
what,
double XL.
what size is it?
120 inches in diameter.
Okay. All right,
It's what?
can you show me your shroud lines on that parachute?
Yep. So it's attached to a swivel.
Got it. Okay. No burn marks,
No burn
No.
marks.
no tang, okay. All right, same thing with the shock cords
Yeah.
and the lengths? How
Hmm?
long are they? How long are the shock cords?
The main chute is 30 feet, the drogue chute is 40 feet.
Okay,
This is the main shock cord. We use Kevlar sleeve. Oh, yeah, Kevlar. We put a Kevlar sleeve around all of our shock cords to make sure that they don't get burned.
Okay, all right. Same size for both main
Yeah.
and, okay, all right.
1 inch diameter.
Any
the one
burn
inch.
marks? Any,
No.
okay. All
No.
right,
All right, our electronics guy is here.
okay, your hard points for the recovery?
Yeah, so the nose cone, we use the aluminum tip. We have a Performance Hobbies Von Karman nose cone, so we have the aluminum tip to bolt into.
Okay. For recovery? You're doing
Yeah.
dual deploy, right? Standard dual deploy? Or are you doing head-end deployment?
This is a standard.
We push our nose cone off with the main chute inside of it. And then the shock cord is attached closer to the avionics area.
So is,
Sophie's AirPods attached.
is the
Yeah.
main stored in the, is
I'm
the
sorry.
main, is the main stored inside the nose cone?
Yes.
And your subscale flight or whatever it was, you flew it the same way?
Yeah.
It was a full scale test flight and it worked.
We flew it to 7,000 feet. We used a smaller motor. That way, if we did have a recovery issue, it wouldn't go as far if there was a problem.
Okay, all right. Can you show me the bulk plates that go on the coupler that houses the electronics?
Yeah, so we have this 1/4 inch bulk plate. And then the other bulk plate.
Okay. And what electronics are you, what recovery electronics are you using?
Yeah, that's lovely.
See, we're using a Blue Raven, a Straddle Logger, and a featherweight GPS.
Okay. All right. Well, come back. You're not done yet.
Oh,
Okay. Are the batteries on the same side as the electronics is? And
we're using 18 650s since we have a lot of them as batteries for electronics.
okay, that's fine. You could have used, you didn't have to do that. You could have used whatever the manufacturer recommended. Really, the only time that we're not really allowing the LiPo batteries to come into play is if you're doing your own electronics. And you're not, so drop it down just a little bit, so, yeah, so I could say, okay. So Blue Raven, Stratologger, okay, and your GPS, right?
Yes.
Where are your switches?
So a bit difficult to see, but the switches are in here already hooked up to the avionics bay.
Okay,
So we're using screw switches. So we have a cord here, and that plugs into here. And then we have a plug for here for the main, the E matches for the main parachute, so backup and main. And then for the drogue parachute, we also have a plug here, and there's two sets. There's a backup and the main one for the drogue as well.
Is Edward there today? Actually, he had the auxiliary. He had the. We have a second battery for our camera for the video streaming challenge, and he had it last.
Edward here?
I don't think so.
Okay, how are those batteries held in place?
So there's some space here. So once we have the batteries in here, we just zip tie them so they don't move.
Okay, okay. All right, that's what I was
And
looking for. Go ahead.
And the auxiliary battery I mentioned is held in the 3D printed mount that bolts through the board.
Okay. All right. Okay, that looks fine. Let's go back to the charge wells. Go back to the bulk plates.
All right, so. Let's right here, everyone. So
Okay.
these also have swivels on them.
Okay, what are the swivels rated at?
I think it's 500 pounds.
How much?
500 pounds, I think. We used these last year. I don't remember the exact rating.
Okay, well, okay. I'm not, I personally not really concerned about it, but the guys in New Mexico are going to be.
Okay,
So be sure that you have your ratings, force ratings for your swivels, your U-bolts, your cable, your nylon shock cords and all that sort of stuff. Make sure you have that handy.
got
Okay.
it.
Okay, because they will. All right, bring it back. We're not done
Oh,
yet.
yep. Got it.
Okay. Tell me how, okay, charge wells look fine. Tell me the procedure in which you're gonna load, how you're gonna load those charge wells. In other words,
That's
okay,
possible.
the procedure you're gonna use.
Procedure for rechargeables.
Having trouble answering the question.
The procedure for loading chargeables. Basically, what we do is we will we connect everything up, we test connectivity. And then once connectivity has been tested, we remove our e-matches and we will load black powder one at a time. And then we put blue tape over it. We also use dog barf, and then we put the blue tape over it.
Okay, in what order do you do that? Or the other way of asking the question is the E-match at the bottom of the charge well or at the top of the charge well?
The EMAT is it's inside the black powder. So either we put the EMAT, then fill it up with black powder, or do the black powder and then put the EMAT into the black powder, and then we put the dog barf on top of that, and then we tape it up.
Okay, so basically the E-match is on top of the black powder.
Yes.
Okay, okay. What you want to do is you want to make sure the E-match is on top of the black powder. That way when it lights, all the black powder comes up through the flame. If you put it on the bottom, you basically push the black powder out and you don't get all you wind up with a really dirty inside because you didn't light all the black powder.
Uh-huh.
So you're good. You're in good shape.
Yeah, this is a learning opportunity. No one explained that to me before.
Yeah, okay, that's fine. You're good. Yeah, make sure it's secure, make sure it's compacted down as tight as you can possibly make it. And good solid tape, duct tape or whatever, work just fine. Doesn't have to be duct tape, it could be masking or whatever, but don't use cellophane tape or something like that. So on that end of it. Okay, so we have head end deployment. All right. Your blankets, your Nomex blankets, or
Yeah.
however you're going to cover your parachutes, protect them.
Here's one of them. We do burrito wrapping, so we make sure the parachute is fully encased in the blanket.
Okay. And when you do your shock cords, are you going to do what's called a Z fold on your shock cords and tape, or just stuff and run, or something
No,
else?
we do Z folds. We don't tape it over,
Okay,
but yeah, we make sure it's well folded.
okay, you can consider taping each of the Z folds with a single layer of masking tape. Believe me, it'll break. When the ejection charges go off and things separate. In some cases, them not breaking is actually a good sign because that means that there wasn't a complete jerk at the end. If everything breaks, then you had a jerk, but the break will slow things down a little bit. Okay, it'll have an impact on that. Okay. So far, believe it or not, good. You're looking good. Okay, you got some work to do.
Yeah.
Okay, but it doesn't look like it's major work. I mean, it's going to take a few hours to put the booster together, but I don't really see a big problem with that. It's not like you're waiting on materials to be delivered or the shop to do something for you or something along those lines. Okay, can you describe your static test and the results and how you calculated what the motor size was and everything?
Yeah, okay. So, OSU was nice enough to help us out. We didn't have a place to test safely, so we used Corvallis Airport with them.
Near Corvallis Airport.
Near Corvallis Airport. We were using their load cell at the time.
Yeah, we were at near Corvallis Airport. Since OSU hosted us, we used our load cell. We used our own pressure sensor. OSU's load cell had issues measuring data, and we didn't really get any usable data out of it. We'll be doing another static test soon during the May 18th, right?
Yeah, so we had a few issues. We're doing another test Saturday.
Okay, can you send me that data, please?
Right now?
Well, and I would prefer it to be in a CSV file
Yeah,
with time, load cell data, pressure data, and what the columns noted as to whether the force data is newtons or pounds, pressure, PSI, or whatever you decide the pressure is in. And you'll be static testing the motor that you'll be taking to the contest, correct?
sorry, they're doing this.
Why are you setting up?
Well, we're setting up speakers, I guess. Find out how this goes.
That might feedback loop.
There.
So have you already cast a propellant?
Yeah, propellant is casted. So we have everything ready. We have 3 motors currently. We have one for the test on the 18th. And then we have another one for a flight test on the 19th. And then we have the one we're going to take to competition. So everything's already cast.
Oh, okay, okay. Okay,
Should I put on Spanish for you?
And then I don't have Wi-Fi. Okay.
Okay.
You are secretary at ESAR Rocket, right?
I'm sorry.
Your email is the secretary at ESRA Rocket.
Yeah.
Okay.
Yep. Who's your flyer of record?
That's me. Dave
Okay.
Hewitt.
Okay. Level 3, Tripoli, all that sort of stuff.
Yeah.
Okay. And just, I'm sure you already know it, but I'll just make a word of caution. Whoever's going down to the pads has to be a member of Tripoli.
Yeah. I think everyone who is planning on going down to the pads currently is a member of Tripoli. You know, me, Rebecca, it's maybe. Are you going to go? Because I do need that. I need everyone's Tripoli member.
Like, you guys really want to, I can.
It's up to you. We can discuss this later.
Okay.
If you're coming.
You don't have to be a member to be a part of, you don't have to be a member of Tripoli and be part of the team. You just can't go down to the pads. That's all.
Yeah. It'll take us.
It's highly recommended that you at least spend the $20 and be a member of Tripoli. You know, you got good insurance coverage. All right. Are you trying to send me your data?
Yeah, I'm trying to find the CSV files I just made.
Okay, well, I'll tell you what, why don't you just pause that for a second and let's go ahead and wrap this up.
right.
I'll look at it when I get it. Okay, we don't need to, this, you can send it to me over the next 24 hours and I'll be fine with that. Okay. I'm going to sort of turn the tables and have the team ask me any questions that they have before the contest, before we get to it. And remember, it is a contest and there are points awarded. It's not just a case of let's go and fly, and it is a contest. So be aware of points and spreads and what's important and what's not important. So that point comes down to points. So questions from the team.
You mentioned them discouraging lipo batteries of using like self-contained systems. Is there any like special precautions we should be aware of if since we're including lipos?
What we don't like and what we've had happen in the past is the lipo batteries that are packaged in what looks like aluminum packaging. It's basically called a soft pack. Those can catch on fire, and we've actually had that happen both on recovery because something came in hot, and we've also had it because somebody did something they shouldn't have on on the field itself and set the electronics bay on fire. So we banned them and we went back to the other chemistry. However, if the vendor recommends that battery and you can order it from the vendor or supplied from the vendor, then you're okay for this year. But
Okay, because
expect that for next year, huh?
we have like a camera for the video streaming challenge that the manufacturer doesn't sell batteries, but it does have to run off of like a drone like lipo.
But do they recommend a battery?
Yes.
No, that's fine.
All right, cool.
Because not all of the vendors who've gone through the hassle of shipping lipo batteries.
Yeah, no, we
Yeah.
recommended by the manufacturer of the camera module. Everything's wired to their manual.
Yep, yep. And we don't want, the other thing is that we've noticed, especially on the SRAD side, is the battery voltage, the sizes of the batteries is probably overkill. So that leads to potential problems too. So
Yeah, I think we've picked a fairly moderately sized one. And actually the way we're setting up the circuit, it should It's going to be triggered by a gravity switch, so it shouldn't actually have any power until the rocket launches. And then
Okay.
it'll connect the circuit.
Okay, all right. Well, good question. Anything, Dave or anybody else have any kind of questions?
Yeah, I had a question on the igniters. So Spaceport requires dual-headed igniters. What I want to do is take two quick burst igniters, the biggest ones, and wire them in parallel and use that. Is that acceptable?
Yes.
I didn't want to spend another $50 for a single igniter like I did last year. That was painful.
Dave, do whatever makes sense. Okay, I mean, you know, my problem with this dual stuff is, and I understand them wanting to try to prevent, you know, misfires. Okay, you still can get misfires with dual, by the way. I mean, it's not a perfect protection. My concern is that the igniter doesn't overpressurize and KO the motor. And, you know, that's a distinct possibility, depending on what igniters you use and all that sort of stuff. So, on that, you know, 4-grain 98 with that probably should be just fine. But, you know, use your judgment on that.
Yeah, when we did the static fire, that's what we lit it with, and it was just fine.
Okay. That's what we do. That's what I force my team to do is, you know, whatever igniter they're going to use, you're going to use it on the static test too. And that way you test both entries. So you know you know what's going to happen. So okay, that's a good question. Okay. Anything else? How many of the members have been to Spaceport before? I know at least one.
I went
Two.
last year with a different team. I was their fire of record.
Okay. Okay. All right. So I'm sure Dave and guys, I'm sure you've educated the team on Spaceport and the environment and all that sort of stuff, right? You know,
Bring water.
bring water. Yeah.
Boots are a must.
Yeah.
Those that mesquite is nasty stuff.
It's got some, yeah, it does.
And then bring sunproof clothing. So if you don't have it already, you need sunproof clothing. You know, basically clothing with a protection rating on it.
Yep, that's all good recommendations. Shoes, you know, you need field boot type shoes. Don't bring sandals because you step on the wrong thorn and it'll go right through the sandal, as an example. So yeah, you dress appropriately. The other thing, sunscreen of some kind. You want to protect your area. It's going to be hot. It's going to be at least 90 degrees. It could be as much as 100 plus 100 degrees, but the humidity is going to be very low. It's going to be like 20%. And so you're really not going to feel the heat, you know, but you're going to dehydrate really fast. So you want to watch out for that.
And the water and sunscreen goes for brothers this weekend too.
Right.
I did not see anybody, myself included, bring a water bottle when we recovered the rocket last time. I don't want that to happen again. I'll bring my water. You guys bring your water when we recover the rocket.
Yeah. Well, yeah, we have a big water truck. It's the only way I can describe it. That's sitting there. You can fill your water bottles up anytime you want to. So, one of the things we're going to change as far as the field is concerned is that you do not need to bring tents with you, nor do you need to bring tables. We're going to tent that whole parking lot with professional size, done by a professional company. So you'll be in the shade. You don't have to lug that stuff around.
Awesome.
Yeah, in the past, with the winds being what they are, you can expect winds in the 20 and 20 mile per hour, 15, 20 mile an hour range. You know, by early afternoon, student tents were going flying and they're more dangerous than the rockets were. So we're going to tent that whole area and we'll give you two, I believe, 6-foot tables. You'll need to bring your own chairs, all the other stuff that you need to support the rocket and yourself. So, and that
I did just remember, sorry.
I'm sorry.
I just remembered a question that I had. So we're doing the video live streaming challenge. You guys will have a capture card that we're supposed to plug our computer or whatever we're doing the video out of.
I don't, ask that question on Hero X.
Okay.
I don't know. I know live streaming is
Okay.
going to be occurring, but I don't know exactly what the details on it are.
Okay, thank you.
Okay, sorry. Okay, we're going to do things a little different at the convention center this year. That's where you'll do your podium presentation, you'll present your rocket and all that sort of stuff. And there'll be the first of, there'll basically be the final safety check. And we're gonna do things a little different. When you register, we're gonna give you a pager. The same kind of pager that you get at a restaurant. And so when your time to bring your rocket up to be safetied, you'll get a page. And you'll rock it up. So you won't have to stand in the hallway waiting for the next one to review your rocket. Be prepared to do exactly what I did. They will take your rocket apart piece by piece. Okay, and they'll tug on the wires on the electronic side and all that sort of stuff. So on that end of it. So that pager will also follow you out to the field. So that when you're ready to fly, you go that safety check you got to go through, you'll get paged for that. You'll get paged to go to the pads and all that kind of stuff. So you won't have to be standing in line waiting like things were in the past. So
Well, that's really good to hear. That was a problem with people standing in the sun last year.
yeah,
Really glad we're not going to be doing that again.
yep, yep. Now, this is the first time we'll be using the pager, so I'm not guaranteeing it's going to go smooth. But at least it should cut down a lot of stuff that was going on before, like standing in line in the sun for an hour while you were waiting for a rocket safety or something like that. So that should be that, take care of that. I can't think of anything else. There will be a couple of on-site vendors there. Wildman will be there. Aerotech will be there. And there may be a couple other two for all I know on that end of, but at least those two will be there. Will be there for the primary side of it on the end of it. So. Okay, anything else? I'm not too worried about you finishing up and having a rocket ready. In the beginning, I wasn't 100% sure I knew what was going on. So, it was little, because I've actually done some reviews where, don't worry about the parts in the shop. They told us they'd get it in time. And we don't want that. We don't want teams building rockets in their hotel room. Okay, we want to make sure the rocket's ready to go and the team's ready to go. You can't build that class of a rocket in a hotel room. So the end of it. Oh, okay. Do you guys and gals have anything else for me? No.
I think I'm good. Thank you for your time.
Oh no, thank you for your time. Like I said, we want to make sure everybody can get to the contest and has a rocket that can fly safely.
Yep.
And have a good time. It's a lot of fun. It's a lot of fun.
I think.
All right, don't forget, shut down the recording. And in the first message I sent out, there's a link to send a link of the recording to. And we want you to just basically post the recording on a shareable drive. Send us the link to the shareable drive. Don't send the video itself.
Okay, we can set up volunteers.
Okay,
All right, great.
All right.
Thank you.
Thank you for
you're
your time.
welcome.
Yep.
Bye.
We'll see you in a few weeks.
In a few weeks.
Thank you.
Okay, bye-bye.
Bye.
Bye. Stop. Stop crying.
All right. So it seems like it went pretty well.
Yeah, that seemed all right.
About a breakdown with there.